Okay, pre-algebra, this is our last section before our test. This is section 1-6. We're going to talk about scatter plots. Our first and only real vocabulary word today is just really discussing what a scatter plot is. And it's a graph that shows a relationship between two sets of data. And so what we'll see in the next couple of frames is an example of what they look like and ways to categorize them. In this frame, I have two scatter plot examples. This first one deals with days versus weight, and that could be anything. I literally pulled it off the internet, but what we can do is what we can surmise is maybe after a certain number of days, people gain a certain amount of weight. There's a certain weight gain, people or rats or whatever. And so each data point represents one person or one element or one thing that is being measured. And so we have this one. So then over here we've got cars and their weight, miles per gallon. So it looks like the lighter the car, the lighter the car is, and maybe this would be in tons or something. The lighter the car is, the greater the miles per gallon is. And so what I want you to observe about these two examples is the fact that, one, they have a trend. Notice that this one kind of trends as the days increase, the weight seems to increase. And this one seems to trend negatively. So this has a positive trend. And this one has more of a negative trend. And I say it's negative because as the weight increases, the mileage decreases. So two ways of categorizing our scatter plots is that they can have a positive or a negative trend. There's another way. Let's take a look. If you take a look at this one, this one also pulled off the internet, seems to be plotting people's rates of impulsivity as it relates to their rate of empathy. And as you can see from my various examples, that scatter plots are really used across disciplines. They're used all over the place in terms of representing data. But check it out. There's no real trend here. If you look, seems kind of random, right? You might be able to connect the dots and draw pictures, but other than that, there seems to be no upward or downward trend, or not negative or positive. None of that seems to be occurring. So here we say that there's none. There's no trend that's going on here. So our first example asks us to make a scatter plot, and I took the liberty of creating this axis so we can do that. Notice that my year is across the bottom, and the vertical direction is population in thousands. And I've chosen to number it so that I can contain all of the information here. I've only used two-digit numbers for the year. That's why we end here at 00 for 2000. And I've also chosen to count by 30s along the y-axis, so that I'm going to write over this 108 real quick. So that would put 330 right there. So with this in mind, now we're just going to plot as you guys usually would. As you've learned in the last section, plotting relations is just another way of showing the relationship between information. So as I plot my points, we get something kind of like this. I chose to use yellow dots to kind of highlight it a little bit more because I recognize that I'm writing on the background just because of limited space. So what we see is we get these dots, this trend of yellow dots, and how would you say it trends? What would you say the relationship is? So in our text we use, when I say trend, we actually call it the relation. Would you say that this is a positive relation, a negative relationship in terms of as the years go by, how does the population fare? Is it positive, is it negative, or is it neutral? Is there no relationship at all? And as you can look, you see that it's going up. I don't know why I did dots there. It's going up. I would say this is definitely a positive relationship. What we did at the end of example 1 was really what we're going to be doing in example 2. Sorry to obscure the directions, but example 2 basically says that we are interpreting scatter plots and we're going to determine the relationship, and that's positive here, negative is back here, or none, or is there no relationship at all? So that's what we're going to be determining. So let's look at this particular example, see if I can get it back. Okay, there we go. Let's look at this example right now. What would you say the relationship is? Does it look like it's trending upward? Does it look like it's trending upward in the right direction or upward in the left direction? Or did you see any relation at all? And I would gather, I see that there's a little bit of an uptick over here, but honestly, I would say that this relationship is none. There's no real defining relationship. There's no noticeable uptick going on here. Analyzing the second graph, we're looking at the hours of video games played and someone's grade point average. I'm sure that some parents would like to look at this and encourage you to study more and recognize that your grade point average would go up if you would play your video games less. Anyhow, what would you say? Is there a positive relationship or a negative relationship? This relationship is negative. We can see that there's a negative trend. It's going up this way. The less or the greater your grade point average, the more you play video games, the greater your grade point average, or we could say the greater your grade point average, the less you play video games. So the more you go up here, the less video games you play, except this guy. This guy likes to play. And that's okay, actually. To have data that doesn't exactly follow in a line is basically what a scatter plot is. But what it does is it gives you an idea of trends. And sometimes you do have something called like an outlier, where apparently the person that is represented here, this young lady or this young man, obviously plays a significant amount of video games but is able to maintain a high grade point average. But that's not the norm. Example 3 requires us to do 3 different things. We're going to make a scatter plot. We're going to draw some conclusions about the type of relationship, meaning we're going to determine whether it's negative, positive, or there's no relationship at all. And then we're going to predict, given what we've determined, some information based on that. So take a look at this. We've got a situation where we're thinking about cups of coffee during being sold in an outdoor game. So depending on the temperature. So depending on the temperature, you can see how much coffee is sold. So at 34 degrees, 42 cups of coffee are sold. 36 degrees, 39 cups of coffee are sold, and you can kind of see how that's going on as you look at the table. So we're gonna do the 3 things asked. We're gonna start off by making a scatter plot. So if you notice, my axes are labeled temperature horizontally, and then going up, this side should be cups of coffee. So after we have our axes labeled, we can then go ahead and plot the points. So taking a look at this plot, we see a definite relationship is being exhibited. So we're going to answer A and B at the same time. So let me write A and B. So a definite relationship is being exhibited, and the relationship that we see here is simply the fact that this is a negative decreasing relationship, right? As the temperature goes up, the amount of cups of coffee that are being sold at this event goes down. So the relationship is negative. Okay, I know this looks totally confusing, but we're looking at part C, and part C says that we are going to predict the number of cups of coffee sold if the temperature were 30 degrees. So what I have down at the bottom is a screenshot of our last screen where we actually made the graph, because I didn't want to make the graph again. And so what I'd like to do is use this screenshot to predict. So we already said that there's a negative trend going on, right? And we know that that trend is going up and back, and we see that as the temperature goes up, the number of cups of coffee decreases, goes down, and so there's a backwards trend in a sense, or a negative trend, or a negative relationship. So we're asked to figure out, and this should be degrees, 30 degrees Fahrenheit. So what I would do is I would draw a line, sometimes called the line of best fit, within my scatter plot, and then figure out approximately where the data point would be if we were talking about if it were 30-degree weather. And if I would continue up with this trend, it looks like this is 10, 20, 30, 40, I say 50 or 60, 50 and 60 there. It looks like, and this is an approximation and other people will get different answers, but if we had, if the temperature were 30 degrees, I think it would be safe to say that the amount of cups of coffee would be approximately 50. So 30-degree weather is going to lead to about 50 cups of coffee sold. So our homework is to complete pages 39 and 40 in your packets. You can also work on the practice test on page 53.